Bright Tuty. Every student matters.
The next topic, that is reflection of sound. Now sound travels or propagates in the form of waves that we have studied, right? Okay. So just like other waves, just like other rays, even though it is rays of light or any substance, these sound waves also get reflected. Means after striking a surface, even they bounce back just like a tennis ball or any ball. Right? So that phenomena in which these sound waves bounce back after striking a surface, that is known as reflection of sound waves. Means, for example, this is a surface or this is a surface. If a sound wave is coming, when it strikes this surface, it will bounce back. Or if the sound wave is coming and striking any particular wall or surface, it will reflect back. Right? Now we have seen laws of reflection in case of light rays. What were those laws of reflection? Let us study first of all. In those laws, we have studied number one, that the incident ray, the normal and the reflected ray. I repeat, these are the three rays I am talking about. I am talking about incident ray, normal, I do not use the word ray with normal, and the reflected ray at the point of incidence. Now what exactly is this point of incidence? We will just relate it shortly. They all lie on the same plane. First of all, let us try to relate what are the various terms we have used. If you know, very good. If don't, then please try to relate. Now, if I am taking an example of a ray of light. So, the ray of light which is coming, this ray of light is known as incident ray. When it strikes any particular surface, the point at which it is striking the surface is known as point of incidence. And after striking back, when it bounces, this ray is known as reflected ray. At the point of incidence, if I draw a perpendicular, that perpendicular is termed as normal. The angle made between the incident ray and the normal is termed as angle of incidence, represented by angle small I, and the angle between the reflected ray and the normal is denoted to be or called to be angle of reflection, represented by angle small r. So these are a few terms that we will be using. I think you are already familiar with them because you must have studied in 8th class, but still to brush these things up, the incident ray, the reflected ray and the normal, they all lie on the same plane at the point of incidence, right? And the second law of reflection said that angle of incidence, that is this angle, the angle between the incident ray and the normal, and angle of reflection, that is this angle between the reflected ray and normal, they both are always equal. So this law of reflection, rather these two laws of reflection, they are applicable on all rays and waves, including light rays and sound waves, right? And to relate it, let us perform an activity. All right, what we will do is, on a table we will take these two identical pipes, right? Now we can make these pipes by chart paper also. The length of the pipes should be sufficiently long, right? We will arrange them on the table near a wall. This is a wall, this is a table, okay? Now keep a clock near the open end of one of the pipes and please try to hear, keeping your ear right over here, try to hear the sound of the clock through the other pipe. Adjust the position of the pipes so you can best hear the sound of the clock, and when we'll just try to measure the angle of incidence and reflection, try to see what exactly is the relationship coming. Let it be the point of incidence, let this be a normal. So, the clock is producing sound wave which is going like this, let it be the incident ray, and after striking the wall, if the sound is coming here, let it be the reflected ray which is coming to our ears so that we can hear it. So, if we measure this angle, which will be angle of incidence, and we will measure this angle, angle of reflection, we will find it to be the same, right. So, this particular activity shows first of all that angle of incidence is equal to angle of reflection. Now, lift the pipe on the right vertically to a small height and then observe what will happen. If you will lift it, you will not be able to hear it, because they should lie on the same plane, right. Fine. So, this is how we can relate the sound waves, they are satisfying the laws of reflection. Let us try to relate this topic with the help of very interesting animated video doing this activity. I hope you would enjoy and you will be able to understand it better. Let us see. This is a video to show the reflection of sound, right. For this, the materials required are, we will be requiring a smooth polished wooden board, a wooden screen, we will take 2 highly polished tubes from inside and watch or a clock. The procedure, how will we do it? What we will do is, we will take a smooth polished large wooden board and mount it vertically on the table. At right angles to the board, we will fix a wooden screen. At right angle to the board, after fixing the wooden screen, then on each side of the screen, I will place a long, narrow and highly polished tube from inside on both the sides. Now, I will place a watch at the end of tube A and move the tube B slightly left or right till a distinct tick of the watch is heard to me. Labelings we have done, we will measure angle PCN and RCN between the tubes and the normal, right. So, ABC, PNR we can just relate, and in a tabular format we can relate the values. For example, the values are coming to be 30 and 30 degrees, I will place it. Then I will adjust the tube A, increasing the angle of incidence continuously by 5 or 10 degrees. I will try to listen to the sound from the tube B, adjusting it, and again wherever I will find the sound to be distinct and proper, I will note down the values and put it in the tabular format. And when I will relate, I will see that at every point in time, angle PCN, please try to relate it with the figure, and angle RCN, they are always equal. Just look at the table above. When angle PCN was 30 degree, RCN was also 30. Again, when I increase the angle PCN, that is the angle of incidence, that is the angle of A and C and N, the pipe A. I increased it from 30, I made it 40, 45, 50, 60. I consistently increased it, and I saw that I needed to adjust the tube B, and in order to hear the distinct voice of the tick tick of the clock, when I adjusted and measured those angles, quite surprisingly, all the angles when I measured, they were always equal to that of angle PCN. So, this experiment illustrates the laws of reflection. 2 laws that we have studied about. One is that the incident, normal and the reflected ray are lying on the same plane at the point of incidence, which is C in this case, and the angle of incidence is always equal to the angle of reflection. Got it? Fine. So, I hope now you are able to understand it better, how sound waves they satisfy the law of reflection.